Greetings, cosmic voyagers. Let us begin our expedition. Ever stop to ponder the river of time? We experience it as a constant and unwavering current carrying us from past to future. But what if I told you that this smooth linear flow is one of the most elaborate illusions crafted by the human mind? Inside your skull, past and future are constantly shifting, blending and warping. Your brain, that 3-pound universe between your ears, is a master chronosmith, forging your personal timeline with every thought, memory and anticipation. It stretches moments of terror into eternities and compresses joyful hours into fleeting seconds. Your brain is not a clock, it's a time machine. Let's delve into the mystery. How does this biological time machine operate? Scientists once searched for a central clock in the brain, but the truth is far more fascinating. Enter time cells, specialized neurons in the hippocampus that encode the temporal dimension of our experiences. Just as place cells map your location, time cells fire in sequence to mark the passage of time within an experience. They provide the temporal scaffolding for our memories, distinguishing events that happen seconds or hours apart. The beauty, there's no single spot where time is kept. The brain relies on dynamic patterns across various regions. Think of it as a vast orchestra, not a single ticking metronome. This system adapts, speeding up or slowing down depending on context or emotion. Studies show time cells form unique sequences for different experiences, creating a temporal signature for each memory. If an experience is repeated, the same sequence fires, reinforcing the pattern. If the duration changes, the cells adapt. This isn't just about remembering what happened, but when. Time cells help us learn new skills, like playing music, by encoding precise temporal relationships. The brain isn't passively recording time, it's actively learning and predicting patterns. These unsung heroes allow your brain to construct a coherent narrative of your life. Now that we've met our brain's internal timekeepers, let's talk about what they're keeping time for. Our memories. We often think of memory as a video recorder, but it's not a recording, it's a reconstruction. Every time you recall an event, you rebuild it, often with new interpretations and details. Why not perfect recall? Because the brain is optimized for survival, not data storage. It extracts the gist, the emotionally salient details, and weaves them into a coherent, if not always precise, narrative. The rate-distortion theory suggests our brains trade perfect fidelity for efficiency and meaning. When you form a memory, bits and pieces are distributed across neural networks. Recall is an act of reassembly influenced by mood, beliefs, and even suggestions from others. Each recall subtly changes the memory trace itself. This is why memories can become embellished, faded, or conflated with other experiences. Eyewitness testimony, once gold standard, is now known to be malleable and unreliable. Your memories are less like photographs and more like impressionistic paintings, dynamic, adaptable, and creative. This reconstructive nature lets us learn, update, and integrate new experiences. It's a messy, imperfect, but powerful system for navigating a complex world. What happens when the brain's timekeeping glitches? Enter déjà vu, that uncanny sensation you've lived a moment before. Scientists suggest it's a temporal mismatch. One brain pathway lags or races ahead, making the present feel oddly familiar. Another theory, déjà vu occurs when a new experience resembles a forgotten memory, triggering a sense of familiarity without recall. Or perhaps a new experience is mistakenly routed through memory circuits, making you feel like you're remembering the present. Stress, fatigue, or neurological quirks can increase déjà vu, but for most, it's harmless. A brief system error. Déjà vu reveals our sense of time is an ongoing interpretation, not a perfect recording. These glitches remind us that nowness and pastness are actively generated states. Our internal time machine isn't infallible. It can misinterpret signals and create illusions of temporal displacement. It's a humbling, fascinating peek behind the curtain of consciousness. The hippocampus isn't just for remembering the past, it's crucial for imagining the future. When you recall a memory or imagine a future event, the same brain regions light up. Our ability to recall detailed past experiences is intimately linked to envisioning future possibilities. The hippocampus lets us retrieve and recombine fragments of memory to create new mental scenarios, a mental Lego set. This is fundamental for planning, creativity, and problem-solving. Patients with hippocampal damage struggle to imagine future events, just as they struggle to recall the past. Our capacity for foresight, empathy, and goal-setting is rooted in memory systems. The hippocampus is a dynamic workspace, running mental simulations to help us prepare for tomorrow. Evolution has repurposed one system for both remembering and imagining. Projecting ourselves into the future is a creative redeployment of reconstructing the past. What happens when the brain's time machine is thrown off by trauma? During trauma, time can stretch into eternity or blur into nothing, linked to stress hormones affecting the amygdala and hippocampus. The brain prioritizes survival, and normal time tagging can go haywire. In PTSD, traumatic memories aren't integrated as past events. They intrude as vivid flashbacks, as if the trauma is happening now. The pastness quality is lost, the memory lacks temporal context. Chronic stress can shrink the hippocampus, making it harder to place memories in time. The amygdala stays hyperactive, triggering responses as if the threat is still present. Trauma disrupts the temporal organization of memory, making events feel unbound from their original context. Traumatic memories are often stored as sensory and emotional fragments, not coherent narratives. The result, a personal history that feels broken, with trauma acting as a fault line. Understanding this helps us develop therapies to reintegrate fragmented memories and repair the timeline. Treatments focus on reprocessing trauma, re-establishing safety, and helping the past become the past. It's about getting the brain's time machine back on track. How do we maintain a sense of a continuous self through all these shifts and reconstructions? The answer, our brain's remarkable ability to create an illusion of continuous time and a coherent personal narrative. Your brain is a storyteller, weaving sensory input, memories, and future simulations into a thread of consciousness. This narrative is actively constructed and constantly updated, allowing you to feel like the same person day to day. Time perception shifts with age. Novelty makes periods feel longer, routine makes time fly. Our personal story is built on this perceived continuity, essential for identity and learning. The brain smooths over gaps, fills in missing information, and prioritizes coherence. This isn't deception. It's a survival mechanism for psychological equilibrium. Our subjective experience of time is a deeply personal, highly constructed phenomenon. This continuous narrative lets us be more than fleeting moments. It weaves our past, present, and future into a life story. So, what have we discovered? Time, as we perceive it, is an active construction, not an absolute reality. Your brain is a storyteller and a time machine, editing the past and simulating the future. This understanding adds wonder to our experience. Our sense of time is a personal creation shaped by our unique brains and lives. Memory is not just what happened, it's what your brain needs you to believe to move forward. Be humble about your recollections, curious about your mind, and forgiving of temporal quirks. Share your strangest memory glitch in the comments, and subscribe for more mysteries on Ackermanium. Keep looking up and keep looking inward.